Question number 31. Which of the given statements is not correct regarding the photoelectric effect? Okay, so the first option it says, a bright light yields more photoelectrons than a dim one of the same frequency. This is a correct statement, students. If you talk about the second statement now, electromagnetic theory of light predicts that more the intensity of the light, greater is the energy of the electron. This is correct, students. The classical mechanics indeed predicts this given statement, that the energy of the electron will be greater if we use a light of greater intensity, but that was not actually true in the experiment. Okay. If we talk about the option 3 now, blue light results in slower electrons than red light. This is incorrect statement, students. Blue light has a smaller wavelength or has a greater frequency, which means that the kinetic energy of the electrons will be greater when blue light is used. Okay, so the third statement is not correct. If we talk about the fourth statement now, the stopping potential is independent of the intensity of the light but depends upon the frequency. This is a correct statement, students. So out of these given statements, the statement given in option 3 is not correct. So for question number 31, we have to mark the correct answer as option 3. Let us look at the next question now. Question number 32. Among the given compounds, the restricted rotation about the double bond connecting the rings is minimum n. So if we talk about the options which are given to us, students, we can clearly see that if you look at option 3, the double bond can be polarized in such a fashion that the 5-membered ring gets a negative charge, whereas the 7-membered ring gets a positive charge. And in this case, both the rings are going to become aromatic. So due to this aromaticity in both the ring, students, this double bond will be in a polarized state, and as such the restricted rotation will be the minimum around this double bond. So students, for question number 32, we have to mark the correct answer as option 3. Let us look at the next question now. Question number 33. Which of the following is not an example of a non-viable particulate pollutant dispersed in the atmosphere? So students, the viable particulate pollutants are the minute living organisms. So students, for question number 33, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 34. Which of the given set of organic compounds do not represent metamers? So if you look at option 1, students, both of them are ethers, and the alkylation around the oxygen atom are different in both these cases. So they represent metamers. If you talk about the second option now, so these are ketones. So in these ketones also, the alkylation around the carbonyl group is different in both these compounds. So they also represent metamers. If you talk about the third option now, these are esters having different alkylation around the ester group. So this is also correct, students. They also represent metamers. And if we talk about the last one, in the last option we have a secondary amine and a tertiary amine. So secondary amine and tertiary amine, they represent functional isomers. So functional isomers are not metamers. So this is not a correct option, students. So these two compounds do not represent metamers. So for question number 34, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 35. Consider the reaction sequence. So we've been given a series of reactions, students, and the examiner seems to be interested in the relationship between the major product C and D which are obtained. Okay. So if we start with the first reaction, students, in the first reaction we have a cyclic ester. It is first hydrolyzed. So it leads to the formation of A. So if we talk about the compound A which is formed, students, it shall be this compound. Okay. Now this A is allowed to react with 2 equivalents of PCl5, students. So upon reaction with PCl5 2 equivalents, we are going to have both these OH groups replaced with chlorine atoms. So this is the compound B which is formed, students. Okay. Now this toluene is allowed to react with B in presence of AlCl3 in excess. Okay. So when this toluene is allowed to react with the compound B along with the presence of AlCl3 as a catalyst, students, this Lewis acid is going to extract a chloride ion. Now we know that chloride ion will be more easily extracted from the acyl group. Okay. So this is more reactive since the carbocation formed is an acyl carbocation which has a complete octet of electrons due to the presence of lone pairs over oxygen. So this chlorine will be extracted, students, with a greater ease, and the acylium carbocation will attack the benzene ring at the para position to where the methyl group is present. Okay. So we're going to have the formation of this compound, students, and now since AlCl3 is again present, so this chlorine will also be extracted. The carbocation will then attach to the benzene ring at this position. So we're going to have the formation of this compound, students. So this is the major product C which was formed. Okay. Now if we talk about the third reaction, students, the third reaction is going to lead to the formation of the product D. Okay. So we have this ester reacting with AlCl3. So students, if we talk about this ester, so we know that the AlCl3 is going to attack at this oxygen since it is more nucleophilic. Okay. So we're going to have the formation of a complex. Okay. So there will be a plus charge over the oxygen. Now students, this is allowed to react with toluene. Okay. So when this is allowed to react with toluene, students, the attack is going to happen from the para position of toluene at this carbon. And this bond will shift over here. Okay. So we're going to have the formation of, we'll try and draw it in green, students. This compound, and then this is allowed to react with H2SO4, students. The H2SO4 will first cause protonation in this case. It will convert into carboxylic acid, and then further reaction with H2SO4 is going to protonate the hydroxyl group and generate an acyl carbocation over here, and that acyl carbocation will attach the benzene ring at this position. Okay. So finally, students, we're going to have the formation of this compound. So this is the compound D which will be obtained finally. So students, the examiner seems to be interested in the relationship between C and D, students, and we can clearly see that the compound C and D are structural isomers as the position of the keto group has been shifted. Okay. So C and D represents structural isomers, and for question number 35 we have to mark the correct answer as option 1. Okay. Let us look at the next question now.